Yes, thank you. Uh, for I think I have some difficulty to for sharing. So I'll rectify it in the later stage. So I think this difficulty will not come in the our next class, that will be on February 3. So what I am telling, yes. So uh, these are the formation. So the heat of hydration can be calculated this way. So this is the I am telling actually. You can compute with the heat of hydration. This is the Q1 that refers that heat of hydration of C3S, and this is the amount of C3S formed, get formed. And I think you already know that. Yes, actually, with the box compound, you can already measure this C3S at any stage of hydration. So with this amount, you can calculate this C3S, and this heat of hydration you already know. So heat of hydration, I am telling the exact value. Yes, the heat of hydration for C3S is around 502 joule per gram, and for C2 is around 260 joule per gram, C3A around C867 joule per gram, and C4A around 419 joule per gram. So these are the heat of hydration, and the quantity you can already prepare from the box equation. So this way it happens. So another thing I want to tell that regarding, yes. So so this is the strength actually. This is the strength contribution of these compounds. You can check with this. The initially the C3S will get the initial actually RD strength development. So within 7 days, it get this RD strength, and then the C2S. After that, C2S get formed. So it takes a longer time duration to get the strength, give the strength to cement paste. And C3 is very less. C4S also is less least for contributing the strength to cement paste or concrete. So this way it works. So the C2S is a long-term strength development is for, and for C3S it actually 7 days. At 7 days it reaches its maximum strength. Reaches its high quite it gains high strength. C3S gives the high strength to concrete. So at end of 7 days. So but you check this, you check with the, see if it is 7 days, it is around 30 megapascal it is showing, around 35 megapascal showing, and but if it is 28 days, so is 28 days, actually it is less, but C2S it is less. So if you compare for each days for contribution of strength to cement paste due to the C3S and C2S. You can easily identify the C3S gives the early strength to concrete and C2S gives the long-term strength to concrete. Now this is the formula already mentioned. This is the degree of hydration, how it forms. This is the K1, and this is the also the experimentally found results 0.2, 0.06, 0.6. K1 this is the formula. And also this is the gel pores I am talking about. This is the gel pores. So absorbed layer is there. So this is each layer. CSH layer is there. CSH. This is all a CSH layer. So so this with this layer, these are bonded. So in this layer, the covalent bond is there, but between this layer, this van der Waals force is there. So in between the absorbed layer, you see in the line, the edge is the absorbed water is the big the because absorbed water is mainly basically in the water that is absorbed due to ionic actions, absorbed water. So and the capillary and the chemically bound water I already mentioned that that it is hard to remove that water. So after I think 110 degrees Celsius, um, yes, I have some around actually 110 degrees Celsius. You can beyond 110 degrees Celsius, you can if you heat it up, then crystalline chemically bound structure get will get evaporated. So and also and the thing that I am also like to mention I also like to mention that absorbed water is due to the dipole when there is an ionic reaction, because at these layers these ions are get formed. Ions are this positive and negative ions, this ionic bond, these ionic actions, these absorbed layers absorbed water get formed. So this way, and also the degree of hydration. This is also another formula is that mass of hydration, that hydrated mass divided by the original mass. So in that sense, you can also calculate the degree of hydration. So yes, so these are the various authors they propose is this CSA structure. So these are the intermolecular bonds and also interhydrated water. So these are the gelatinous structure. Actually, these are all the gelatinous structure and this power. And he is showing that larger capillary space and gel pores. So actually, the capillary means when there is a saturation, then because of the surface tension forces, this capillary force capillary water get formed. So this capillary water, whatever space this occupied, is also capillary pores. And gel pores means inside the gel there is some formation of gel pores also takes place. So there's also calculation finding the gel pores. So I think these slides also mention these calculations. So this is the gel and also I mentioned one part. Actually, this bonding actions also um, also includes the specific surface. So when there is a fine material, so there the specific surface is more as compared to the coarser material. So so the specific surface is actually inversely proportional to its diameter. So specific surface is the formula is like the surface area. See, this is mainly the these particles or whatever the particles that are mixed together to make the cement paste are any granular particles. This CSH is the made afterwards at the end of the process. But before it was the particles are granular. It's used to be granular. So for the granular space, when there is the small size grinding is small, so the reactivity with the water is much more because the specific surface is much higher. So and it's in inverse proportion to d, means diameter. So if you calculate it, if it's like for one sphere it is this surface area is 4 pi r square divided by 4 by 3 pi r cube. So if you calculate it, it comes by 6 by d. D means diameter of the particle. So with increasing the diameter of the particle, the specific surface area is less. So with the decreasing dia or the lesser dia, specific surface area is more. So it exposed to higher area of reaction. So it reacts more. So the ionic reactions will be more. So the grinding part is also it plays a crucial role in hydration. So this is the gel pores in the paste. The gel is colloid size particle having 28% characteristic porosity involving pores of the average width of 15 Armstrong called gel pores. So these are the dimensions of the gel pores, right? So capillary pores. So three pores. This is mainly two pores as there: gel pores and capillary pores, right? So you can calculate it. So mainly main contributions of pores come from these two. And another besides of this is macro pores due to air entrainment and macro pores due to pore compaction. So this is the formula of that chemically bound water that I've already mentioned. So this A1 into A3 is this A1 is the this how much water is required for hydrating 1 gram of for full hydration of this C3S, for full hydration of this complete hydration of C3S, 1 gram of C3S. C2 is one hydration of C2S. So this way it forms. So this is the cement content by gram or weight, kg or whatever. So these are the formulas, and also with the so I some made some based on that. So I'll shift to my slides that I prepared. So now these are the I think these are the assignments questions and the probable answers. I also expect your interactions, and this is the as what I what I based on the literatures and that what I think is right, I have mentioned here. So let us come to the question. First question is which of the following properties is the weakness of the cement? So low life cycle cost. Yes, it's good for low life cycle cost. Moldability is good. Moldability. Robustness. Yes, robustness should be there. For robustness, it can't be the weakness. So one option is left is brittleness. So how much CO2 um, is produced during 1 ton of ordinary Portland cement? 1 ton production of ordinary Portland cement. So here actually there's a lot of confusion and also some also uh, um, some hypothesis is there, but actually its average 1 ton of OPC produce 1 ton of CO2. So actually the CO2 how it's come, how it is the exothermic reaction. So I want to show you this. If you if you see a CO3, actually a CO3, CO3, it is if you if you heat it, if you heat it, then it forms CaO plus CO2. This exothermic reaction, so it liberates heat. Endothermic reactions, it suck heats or it absorbs heat. from the atmosphere. The exam unit liberate it. So when there is a production of OPC, so some CO2 emission also, greenhouse gas emission also there. So it's around 1 ton. It's average 1 ton. Actually, it is in range from 0.74 ton to 1.25 ton of CO2. Actually, I have also made one document. Such one document you can search it. Yes, this paper, the International Journal of Sustainable Built Environment. So actually, it shows this. Yes, this is the each ton of OPC production requires 60 to 130 kg of 60 to 130 kg of fossil fuel or equivalent depending on the cement variety and process used, and about 110 kilowatt hour electricity is required. An average zero point 0.9 tons of CO2 emissions per ton of cement produced with the, and with the rest attributed to the calcination process. So like only there is calcination process, it also contributes some CO2, but that is negligible. So here it mentioned, this paper mentioned zero point 0.9 tons. So there's a lot of variation. So now the integrated formulation is the C3. Sorry, this is the formula of this entering guide, that is calcium sulfoaluminate. Now the by adding what is the purpose of gypsum to prevent flash shed. Flash shed property is quickly setting, so it prevents the flash shed. So it doesn't reduce the setting time. It reduces the heat up. No, it increases strength. Yes. So all are so it is reduces hydration, increases strength. So all are there. So it prevents uh, mainly purpose of this prevents the flash shed. So, so all are is not these are not relevant. Reduces sitting time, no. Reduces heat of hydration, no. Increase the sitting train, no. So and these are following compound. There's a minimum heat of hydration. So I can just quickly tell that this ascending order. So this is the yes. So I'll tell this is a C3 case considering the C hydration ascending order. So maximum heat of hydration is the C3A. So minimum is the C2 base. So C2 base. C2 base. C2 base less than C4A. 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 C3S. Then C2S. C2S. Right. So these are the chronology. So this is the fineness. So fine fineness is the cement is in property. So this is the soundness of the cement. Actually, soundness the ability to not change the property when the water get mixed with it. So this is the soundness of soundness test also there. So material which is sound doesn't get cracks or structural weakness easily. So this is the sole reason of cement being very useful. So consistency, the uniformity of cement, uniformity in particle nature is what it makes the whole material very consistent. Due to regularity, the whole finished product is very consistent in strength. Setting time means there's final setting time, initial setting time. So these are the properties of cement: heat of hydration, already mentioned. So compressive strength, yes, with the compressive stress. So flexural, and these are the flexural strength. So the flexural strength also is a type of rupture, modulus of rupture. So flexure is carried out with the 40 by 40 by 160 cement mortar beam is then loaded to the center point until it failure. Permeability is a measure of the amount of water, air, and other substances that can enter in the concrete mix and concrete contain pores that allows the substance to enter the deeper. Okay, so I think okay. So the coefficient of thermal expansion is the thermal expansion coefficient, the rate of coefficient thermal expansion refers to the rate at which the material expands with increase in temperature. Drying shrinkage is the occurs when water starts evaporating from the exposed surface and the moisture. Uh, yes, the drying shrinkage means when water is there and get evaporated, and due to that evaporation, that void space is there and the sinkage is there. So the dry sinkage occurs when the water gets evaporated from the exposed surface and the moisture differential. Moisture means outer side is the moisture is more and inner side is less. So along the depth of the slab causes the strain. Yes, the strain is there, which includes the tensile stresses, and due to this the drying synthesis takes place. Shear strength of concrete is defined as its ability to resist the forces that causes the material inner structure to slide itself. So shear strength means this shearing actions, so one layer to another layer, shear strength. So specific heat is the cement has a very low average specific heat of about 0.92 kilojoule per kg Kelvin, meaning that it gains and loses heat rapidly when exposed to the higher temperature. So, and also there's some property compressive strength, Young modulus, Poisson ratio, tensile strength is also there. So this is now the second I prepared. This is gypsum. So this is the gypsum that grind at the ultimate stages of that clinker formation. After the clinker formation, it grounded with this gypsum. So these are the laws of gypsum is naturally occurring mineral mined with the deposit from the ancient seas and raw materials. So we can find it a very um, you can in your standard details you can find. So I have just mentioned some of it for your references. So when gypsum is added in manufacturing process, the cement clinker formed. These cement clinkers are cooled down and added with some amount of gypsum. The mixture then sent to the final grading process. For ordinary Portland cement, it remains about 3 to 4%, and in case of quick setting cement, it's around reduced to 2.5%. So based on this reactiveness of the cement, so gypsum also get varied. The amount of gypsum get varied. So load of gypsum, main purpose of adding gypsum is to slow down the hydration process. As similar and mixed up with it. So it involves hydration. The process involved in hydration of the cement is that when the water is added to the cement, it starts reacting with the C3A and get hardened. So when gypsum is added to the cement, the water is added to it. React with the C3A particle takes place in form to ettringite. So it reacts with C3A, it forms the ettringite, and the ettringite is initially formed a very fine grained crystal, which forms a coating of the C3A on the C3A particle. So these crystals are very small to bridge the gaps between particles and cement. So this crystal, uh, see the particles, the crystals are too small to bridge the gap. Actually, this is crystals are gelatinous structure and spike-like structure. I'll come to the I'll come to this ettringite. later on. So these are the effect of ettringite and there's a gypsum that prevent flash shed. It retards the setting time, allows the longer working time of mixing when the water is mixed. Cement eliminate its sulfate gate react. So these are the effects. So and the advantage of gypsum deliver smooth surface. Yes, used to the plastic material if properly done with would provide us a smooth white finish. So balanced indoor atmosphere. It is environmentally friendly. It is fire resistant in nature. It has high thermal and acoustic insulation. It provides good aesthetic and functional features. Ease of installation and variety of gypsum product. This variety of gypsum, large variety of gypsum products are available to meet several practical and aesthetic requirements. So these are the advantages that can be met by gypsum. So this is the etching guide. So this is the etching guide where the gelatin structure is formed. So this is the the cement on the CSA gel. This etching guide is getting formed. So actually, there are some few points on etching guide. This is the calcium sulfonate. You can check this introductory set, and now I can tell you this is there's also the primary and secondary eating guide. So at early stages it formed it is a eating guide. The call is primary eating guide. Actually, the eating guide when it formed it get also dissolved, and when there is a thaw action actually actually, yes, this is the second point. The first point I just want to mention this. It has been known that many years, yes, primary eating guide can slowly dissolve and reform in any available voids on microcracks. So this is why the micromorphic, actually, this is a microscopic structure, and always if you find there is a concrete and you see in microscope the eating guide, you will see the eating guide. So and so examine a needle like this is a needle like structure and crystal this is a crystalline structure. So these are forms including so these are again the second point is that sorry the second point is that like any deterioration when there is a freezer thaw action or alkali silica reactivity, so it accelerates the rate of heating guides. Accelerate of eating at which it leaves its location to the final solution and recrystallize in the larger space, such as void and cracks. So this is because both water and space must be present for the crystalline to form. So whenever there is a alkaline reactions or the freeze thaw actions, the eating guide will leave the place, so it moves from one place to another. So and recrystallized it. So the space can be provided to cracks. Um, yes, when there is a crack, the space can be provided by cracks that forms due to the damage of frost action and alkali silica reactions and thermal. Okay, yes. So when there is a alkali silica reaction or freeze thaw action, the damage will cause and there is a cracks will there and integrate will form inside. So it doesn't mean that integrate will also increase the crack. So whenever there is a space, there is a water and space, the integrate will form. So in addition, deterioration caused by such mechanism, greater surface area exposure and easier path of ingression. So and also the deterioration takes place. When the deterioration takes place, there is also water can comes inside and go outside. So, so 18 grade crystal is the nanometer, 2 to 4 nanometer cross section and 30 to 20 to 30 micrometer long. So, under the condition of extreme deterioration, repeated wetting and drying, the 18 grade fill the void, but it doesn't mean that it is deteriorating the concrete surface. So these are the so when there is a decreased recrystallization. So first stage the crystallization. When there is a recrystallization process, then it makes the secondary ettringite. So the secondary ettringite is not detrimental to the performance of the concrete. So these are the questions and the probable answers. So you can find this in your I will upload it and you'll find this quite easily. So these are the regarding some information regarding the editing guide. See, from this you can find this for this more about the editing guide formation. And also there is a final setting of a cement that I already mentioned, that I have some slides or some backups related to final and initial state of the cement, where the balance is made and high cut average rates is there. We can stop. We have the stopwatch, and the process is like that. This is the packet operators, and this is the plunger. Actually, from the for the initial set, we use a plunger of 1 mm dia. For the final set, we use a plunger of we use the needle of 5 mm dia with annular space. So the initial set is from the introduction of water till till it reaches to 5 to 0.5 plus minus zero point 0.5 mm measured from bottom. So it is the initial state, and final state means this 1 mm needle is replaced by this 5 mm annular space needle. So when there is a it is final state, the annular space fail to make some impression, but needle makes some impression. So in that way, it summarizes this initial and final setting time. So you can go more about it. So I'll share this picture. So these are the questions you can write. So we'll discuss in next class. You can quickly write these questions, or you can have the you can find the solution with it. So I can also, in the next class, will be solving these questions. The computer degrees of hydration, compute degree of hydration based on the bilinear, or sorry, the bilinear, that is I mistakenly bilinear is not this. These are the based on a plot, 28 days per water cement ratio plot for M3 grade concrete at the rate of the 10 days of hydration. So with the 10 days of hydration, you can you can find with the water, sorry, this is the M30 grade concrete. You can easily find the water cement ratio from here, and with the K1, K2, K3, you can easily find yes, you can easily find this degree of hydration. So, and also compute the hydrated mass of the cement paste. I already mentioned this hydrated mass is the mass hydrated by the original mass. So this way it can summarize. So so you can try this. So the already you have slides and you have the formulas also there. So it is basically formula involves this H is K1 ln W by C plus K2 ln T plus K3. So based on that, using this formula, you can calculate the degree of hydration. Also the thirdly, this is the two questions all based on this chemically bonded water that the relevant information is already mentioned here. So this 0.3 is nothing but A1, A2, A3, A4. So all for all for C3S, C2S, C3S, I gave 0.3 gram, because 0.3 gram water is required to hydrate fully the C3S, 1 gram of C3S, 1 gram of C2S, C3, 1 gram C3, and C4S. So the halide is that C2S, halide is a C3S is the halide, C2S is the halide. So you all know the information in compute the chemically combined water. And lastly, the question is like the computer volume of solid hydrated product, gel pores and empty capillary pores, if 60% hydration of the cement paste is get completed for a cement mass of 100 mm. Specific gravity already mentioned, the cement is 3.15. Take the specific gravity of hydration product 2.51. Also find the hydrated volume of cement and volume of capillary water. Cement, note that 1 gram of cement takes 20.23 gram of water for complete hydration. So I think the will not get it will not get finished within short period of 5 minutes. So it will take some time. In the next class, if you solve, I expect from you you solve this on your own, and we'll discuss in the next class. So that now I come to some more questions. Yes. So I'll also show. I in the beginning, I already mentioned that I'll show in daily basis. Let apart from keep apart the lectures and all these things. So this question will be helpful for you in developing your knowledge and cracking the competitive exams. So these are the questions. So we'll discuss. So you can. Yeah, I think all of you, many of you have already gone through these questions, but I still insist that you please take a note of this. There's many people are there that has less information about it. So, so please be patient and keep on writing this these questions and answers. So we'll discuss it by uh, yesterday or that the next class. We'll discuss it. So these are the questions. So first of all, I will try to explain. That is the compaction of the cement helps in segregation of the aggregates, removal of the excess water, increase the density, addition of required air fluids. Compaction of concrete. What does it mean? So it doesn't segregate the aggregate. So this how when there is some multiple choice question, you have to just apply your brain and remove the irrelevant or not applicable points. So with that you can easily solve this, find out the solution of this question. So removal of excess water, no, increase the density, addition of required, no, these 2 points are not there, yeah, not right. So removal of excess water, increase the density. Mm, more thing is in removal of excess water, compaction is right, increase the density. Yes, removal of excess water. uh, Compaction, yes, compaction. Yes, compaction is removal of excess water, you can say. The concrete attains major part of its strength is 2 weeks, 1 week, 2 weeks, 4 weeks, and 5 weeks. So I think it's 7 days. I think it's take a major is gain of strength. So you just go through these answers questions, and we'll discuss it by tomorrow. I'll prepare the questions for you, and I'll have the solution. We'll sit together and solve it. So it is about 20 M20 gauge count is 20 Newton per meter square, millimeter square. Strength and quality of the concrete depends upon grading of uh, grading of aggregate, surface area of aggregate, surface texture of aggregate. So all of it. So concrete having slum of 6.5 meters 6 to be. So these are the questions that you can readily available in the text. You can easily note it down, and I'll also keep a document of it, and will tell you solution. Separation of separation of water, sand, cement from the freshly mixed concrete is called um, see, separation of water, cement, water, sand, cement is called bleeding. It's called bleeding. Separation of water, sand, and cement from freshly mixed concrete is called bleeding. So segregation means that aggregate get separated.